Hi everyone. Are we live? Can you all hear me? Can you hear me, guys? Can you all confirm if you can hear me? Am I audible? Am I visible? Lot of chats going on, huh? Great, great. God bless you all. All right, I think we're live. Yes, good evening, namaskar, sat sri akal, salam alaikum. I hope you're all well, fine, healthy, safe. Great to have you guys. I welcome you all to this session wherein we're going to discuss some amazing tricks, some amazing shortcuts, techniques related to trigonometry. This is one of the most difficult chapters because of the simple reason that it has a lot of formulas. A lot of formulas. When you get into class 11th and trigonometry is being taught to you, this has a lot of formula that ultimately students start hating trigonometry. Yes or no? Yes, I am sure. And this happens with a lot of students, particularly the ones who have not studied 11th class trigonometry in class 10th. I mean, these days there are a lot of kids who already do class 11th trigonometry in class 10th or 9th itself. But again, there are a lot who study trigonometry of class 11th in class 11th, and ultimately they face a lot of formulas and ultimately they start hating this particular chapter, and they never develop the kind of liking for trigonometry. But as I've told you in one of the sessions before, the weightage of trigonometry in exams like JEE Advanced is huge, is humongous, and this is one chapter that you should not be ignoring, because by this time, by the end of class 12th, trigonometry is used in a lot of chapters. Right from, matrices and determinants, a lot of questions of trigonometry there, then calculus, integral calculus, differential calculus, it is all, based out of trigonometry. And then at the end, there's also vectors in 3D, wherein there is a bit of trigonometry there, right? So a lot of chapters in class 12 have trigonometry. So even if, trigonometry is not that strong by the end of class 11th, by the end of class 12th, you apply these formulas so much that they automatically become the part of your body. Right, but again, as far as JEE Advanced is concerned, there are certain direct questions which come from trigonometry, and the weightage is huge. So that is why this special session for each and every one of you, so that you are able to do these kind of questions. There are certain common concepts which come in JEE Advanced as far as trigonometry is concerned. So we'll be studying those concepts, and also we'll be doing some questions based on those concepts. This is my Telegram ID for those who need any kind of help related to mathematics, Olympiad or JEE preparation. They all can reach out to me at this Telegram ID. All right. So this is the weightage. This is the weightage of mathematics as far as the top 10 chapters are concerned, and you can see trigonometry is right up there. 11% in 22, 10% in 21, 9% in 20, 9% in 19, 8% in. So basically trigonometry is one chapter which gets intermingled with every chapter, So that is why there are a lot of questions which we see on trigonometry. Of course, there are certain questions which only involve trigonometry, and there are certain questions which involve certain other concepts with trigonometry. But again, as a whole, trigonometry is huge. You can see one chapter covering almost 11% of the entire syllabi is huge. So this shows you the importance of trigonometry, and the fact that you should not and you cannot be ignoring this chapter, whether you are going to give JEE Advanced in 10 days from now, whether you are preparing for 24 or 25, you cannot ignore this chapter, as simple as that, because the applications of trigonometry are there in each and every chapter. Got it? Okay, so as in every lecture, there is an homework which is attached at the end of the session. Right, so these are important points which I have discussed. So let us discuss some certain fine points as related to trigonometry. So first and the most foremost important thing is graph. You should be very well aware of all these 6 basic trigonometric function graphs, and not only trigonometric but also their inverses, and not only the inverses but also sine inverse of sine x, cos inverse of cos x, tan inverse of tan x. So these graphs you should know, and if there is any confusion, you should go back, read your notes and study these, because these are very important. So sin x, it is like this. One more important thing is this area. So area of one loop of sin x is 2 square units. Very important, you should remember this. So this area is 2 square units. So half area, because sin x is symmetric about pi by 2, so 0 to pi by 2, it is going to be 1 square unit. Right, so 1 unit, whole loop is 2 square units. Very, very, very important, guys, very important. Right, so you should also be knowing where sin x becomes 0. So sin x is 0 at all these points. Sin x is 1 at pi by 2, 5 pi by 2 and minus 3 pi by 2 and so on. Right, so all these points it should be there on your tips. Right, so you should also know when is sin x is equal to sin alpha, general formula. So this is x is equal to n pi plus minus 1 to the power n into alpha. Right, so this is a general formula that we use for trigonometric equations, and you should know how to prove this, right? Right, so this is one. Cos x, again, shift the entire graph by pi by 2 towards left and you get cos x. So this is the area, this is 2 square units. So area is exactly the same. So area of one loop of cos x, 2 square units. You should know that at odd multiples of pi by 2, cos x is 0. So cos x is equal to 0 at odd multiples of pi by 2. Very important. At even multiples of pi, 0, 2 pi, minus 2 pi, 4 pi, minus 4 pi, cos x is 1. At odd multiples of pi, cos x is minus 1. Also guys, if you draw sin x in this graph, let us try to draw sin x in this graph only. So it is going to look like this. It is going to look like this. Right? So it is going to look like this. So again, you can see that at all the points where sin x is 0, cos x is 1. Sin x is 0 here, cos x is 1 or minus 1. Sin x is 0 here, cos x is 1. Sin x is 0 here, cos x is minus 1. 0 here, cos x is 1. So whenever sin x is 0, cos x is plus or minus 1. Whenever cos x is 0, sin x is plus or minus 1. This is also one thing that you should know. Also, this area of one loop between sin x and cos x. Area of one loop between sin x and cos x. By the way, this area expression, you can easily find out using this expression, pi by 4 to 5 pi by 4 sin x minus cos x integration. So upper curve minus lower curve. So this area, this between, this is 2 root 2. Right, so you should know this. You should know this, right? Sin x versus cos x. So again, very important. Then we have tan x. The range is minus infinity to plus infinity. The periodicity is pi. So after every pi units, it repeats itself. So periodicity is pi, minus infinity to infinity. The range is all real numbers. Not defined at these points. So wherever we have dotted vertical lines, tan x is not defined because tan is actually signed by cos. So at all the points where cos x is 0, tan x is not going to be defined. As simple as that. So you should be very well aware about these. Cot x exactly same. Cot x is cos x by sin x. So at all the points where sin x is 0, that is 0, pi, 2 pi, 3 pi, 4 pi, at those points cot x is not defined and a graph is exactly the reflection, kind of reflection of tan x. This is secant x, right? So range, secant x belongs to minus infinity to minus 1, union 1 to infinity. So range of secant x, secant x, the value is either greater than equal to 1 or less than equal to minus 1. Moreover, secant square x is always greater than equal to 1. You should know this. Secant square x is always greater than equal to 1. Cosecant square x is always greater than equal to 1. So these graphs should be very clear to each and every one of you if you want to attempt a good, trigonometry, you want to do all the questions of trigonometry in JEE Advanced. These graphs are the must for each and every one of you. Alright, so these are certain formulas which you have to use. These are must use formulas. Apart from these are certain others which I'll write. So one is tan A. I'll write it here. So whenever in life you find 1 plus cos theta or 1 plus cos 2 theta, you always write 2 cos square theta. Whenever in life you find 1 minus cos 2 theta, you write it 2 sin square theta. Right, so entire life, whenever you see this expression, you have to use this because without this, the life is going to be very, very, very troublesome and difficult. 1 plus cos 2 theta is 2 cos square theta. 1 minus cos 2 theta is 2 sin square theta. Whenever you see sin theta, cos theta together, you have to multiply and divide by 2. 2 sin a cos a becomes sin 2a. So these are the three things which you have to use no matter what. Whenever you see these expressions, you have to use. Moreover, there are certain other formulas. For example, cos square a, from the first formula, cos square a is 1 plus cos 2a by 2. From the second formula, sin square a is equal to 1 minus cos 2a by 2. And tan A, you can write this is 1 minus cos 2a upon 1 plus upon sin 2a. Upon sin 2a. So these are the three very important formulas, because what they're doing is they're writing small angles in terms of big angles. So what they're helping us with is we're able to write with these formulas, we are able to write small formulas, small angles in terms of big angles. So small angles, sin A, cos A in terms of cos 2A, cos 2A, cos 2A. Right? So we are able to write small angles in terms of big angles. So this is very important. These three formulas are used in questions like anything. Right? So what they are helping us to do is, I'm repeating again, they are helping us to find small angles in terms of the big angles. Right? So these three working rules, these three important formulas, you have to remember these. Very important. Okay. Now these are two important values. Sin 18 is root 5 minus 1 by 4. Cos 36 is root 5 plus 1 by 4. You should also know sin 15, which is root 3 minus 1 by 2 root 2. You should also know cos 15, which is root 3 plus 1 by 2 root 2. Sin 15 is same as cos 75. Cos 15 is same as sin 75. You should also know the value of tan 15. Tan 15 is 2 minus root 3. Tan 75 is 2 plus, although you can find these values again, but again you should know that, because a lot of questions these expressions get used so that you directly have an idea that which angle is this. So tan 15, tan 75. Also guys, if possible, tan of 22.5 and tan of and cot of 22.5. Can anyone tell me what is tan 22.5? Can anyone tell me, does anyone remember this value? Tan 22.5, what is this value? What is this value? Tan of 22.5, does anyone remember this? Let's see. Is there anyone? Okay, if you don't remember, try to find this out. How will you find this out? Using the same formula that we use here. Tan A, tan 22.5, see, tan 22.5 is 1 minus cos 45 upon sin 45. So 1 minus 1 by root 2 upon 1 by root 2. So this is root 2 minus 1 directly. So in one line you are able to find this. Tan 22.5 is root 2 minus 1, and this will be root 2 plus 1. So these are certain standard values which you should be remembering. Amazing, Zach. Yes. So these are certain standard values. Again, typical and different from the typical values, that is 0, 30, 45, 60, 90, which you should be knowing, right? Although you are able to calculate these values, you will be able to calculate these values in exams also, but again that is going to take time, and sometimes in exams the questions are such that these direct values are used. So you don't get an idea. You know, if you don't remember these values, you have no idea what angle is talking about. So it is always better that you remember these values. Okay? Super. Super. Then there are these important formulas. Again, angles are in AP and with cosines. So angles are in AP and cos is there, angles are in AP, sin is there. So these are standard formulas that I'm sure you must have used. I'm just writing it to tell you the importance of these formulas, that these formulas are not to be ignored, because JEE Advanced, a lot of questions have come on these formulas a lot of times. Right? So a lot of times these formulas have been directly used in JEE Advanced. So again, if you're planning to ignore them, do not do that, because you can pick up JEE Advanced previous year questions, and a lot of times these formulas have been used. Okay, so you have to remember this, very important. Now again, sine of supplementary angles are same, cosines of supplementary angles are negative with each other, right? Very obvious stuff. Now you should also be able to observe certain complementary angles. For example, these are complementary angles, supplementary angles. They add up to pi, supplementary angles. Supplementary angles, they add up to pi, supplementary angles. These are complementary angles. Can you see that? Complementary angles, because pi by 5 is actually 2 pi by 5 and this is 3 pi by 5. Sorry, 2 pi by 10 and 3 pi by 10. So 2 pi by 10 and 3 pi by 10 adds up to pi by 2. So these are complementary angles. So you should be actually knowing about them. Right? You should be able to identify them. What are the complementary angles? What are the supplementary angles? Because in most of the questions, whenever multiple angles are given, right, so there would be certain combination of complementary and supplementary angles that you have to identify. Right? So you should keep your eyes open. Which of the angles are complementary, which of the angles are supplementary, because they would help you a lot in reducing the calculations. Right? So this is very important. This is complementary angle. You should be able to observe these kind of things. Okay? Okay. Now the next concept is a sin x plus b cos x. You should know that maximum value is root of a square plus b square. And minimum value of this expression is minus root of a square plus b square. So again, a very important thing, very useful thing. So maximum value of root of a square plus b square, minimum value minus root of a square plus b square. You should also know that this expression has two variables, sin x and cos x. And if required, I can convert this into an expression having a single variable. I can convert this expression into a sine, single expression of sine, or a single expression of cos. You should be knowing that. Right? So these are important things. I'm not discussing the things as a whole, but I'm telling you the important point that you should be remembering, because we will be all using these in certain kind of questions that we do today. Again, tan a plus cot a, very important, tan a plus cot a. So let us try to simplify this. So this becomes sin a upon cos a plus cos a upon sin a. So as we simplify this, sin square a plus cos square is 1 upon sin a cos a. And whenever you see sin a cos a, you multiply, divide by 2. So 2 upon sin 2a, and this is 2 cosecant 2a. If possible, remember this, 2 cosec 2a. So tan a plus cot a is 2 cosec 2a. Tan theta plus cot theta is 2 cosec 2 theta. Very important. Tan 15, just to give you a little feel, tan 15 plus cot 15 is 2 cosec 30. Tan 45 plus cot 45 is 2 cosec 90 degrees. Tan 30 degrees plus cot 30 degrees is 2 cosec 60 degrees. Tan 10 degrees plus cot 10 degrees is 2 cosec 20 degrees. Right? So this is one formula that you should remember, because it is very useful. Right? Apart from this, you can also, if possible, remember these kind of things. For example, tan A plus tan B. You should, even if you don't know or remember the formula, you should know that this can be converted into this kind of expression, sin of A plus B upon cos A cos B. Tan A minus tan B is sin of A minus B upon cos A cos B. Right, so you should know that even if you're not able to remember those formula, but this can be converted into a formula. But this is something that you should be remembering. Tan A plus cot A is 2 cosec 2a. Got it, everyone? Yes? So these are certain important things which can be used, which will be used, which are used in a lot of questions which can come, which have come in JEE Advanced, and this adds up to our advantage, as simple as that. Again, if a simple question is going to be there, everyone who is writing JEE Advanced has little knowledge of trigonometry is able to do it. The only thing is, if we are able to, if it's a simple question, we should be able to do it quickly, save time, and again use that time in some difficult question which others will not be able to do. So easy question, everyone is going to solve it. It is a matter of time. Are you able to solve that easy question in a good way? Are you able to save time? And are you able to use this time in a difficult question? Because this time is going to be the most crucial thing. Yes? Super. Super. So let us start with the questions, guys. So let us start with the questions. So some of the questions today are going to be, tricky. Let's see. So value of sigma tan square k pi by 16, k varies from 1 to 7. Tan square k pi by 16, k varies from 1 to 7. Let's see who is able to find this. Tan square k pi by 16, k varies from 1 to 7. So the first point The first point should be, we should be able to write them. Let us see what this expression says. So it has 7 terms. The first term being tan square pi by 16, tan square 2 pi by 16, tan square 3 pi by 16, tan square 4 pi by 16, tan square 5 pi by 16, tan square 6 pi by 16, tan square 7 pi by 16. So ideally you should not be writing all this expression. You should know that, right, this straight away becomes simplified. So what is the first thing that you are able to note? What is the first thing that you are able to note in this? You can see that this angle and this angle are supplementary angles. Likewise, this and this are supplementary. This and this are supplementary. This anyways is pi by 4. Tan pi by 4 is 1. This clearly is 1. Right? So if this is supplementary, so we know that tan of pi minus theta is minus tan theta. But squaring doesn't affect. So tan square of pi minus theta is going to be tan square theta. So if it is square, it doesn't really matter. It is always going to be positive. So effectively, this angle is tan square pi by 16 only. This is tan square 2 pi by 16 only. And this is tan square 3 pi by 16 only. Oh, sorry, not supplementary. These are complementary. These are complementary, sorry. By the way, these are complementary angles, yes, not supplementary. Oh, everything got removed, huh? Oh, this is there. Okay. So these are not supplementary, these are complementary angles, by the way. Okay. Pi by 16, 7 pi by 16 adds up to 8 pi by 16. So these are complementary angles. I made a mistake. Right. So basically tan of 7 pi by 16 is tan of pi by 2 minus pi by 16. So this is cot pi by 16. So this is going to be cot square pi by 16, cot square 2 pi by 16, cot square 3 pi by 16. This is going to be 1. This is going to be 1. Right. So what do we have here is, we have 3 pairs of complementary angles. So again, tan square pi by 16 plus cot square pi by 16 plus similar other pair and similarly other pair. So there are going to be 3 pairs plus 1. Plus 1. Right? So this is there. So again, there is no need to write this because whatever happens here, the same thing is going to happen here. So this is the important point. Whenever there is this big an expression, you don't have to write every expression here. Just simplify one and again apply the same formula there. As simple as that, right? For example, if I want to simplify this, if I have to simplify this, I will not simplify this using pi by 16, I will simplify this using pi tan square a. So basically, how do I simplify this? I will simplify this using this. So this expression I will simplify as tan square a plus cot square a. Tan square a plus cot square a. Now what is tan square plus cot square a? Can I say this is tan a plus cot a whole square minus 1. Can I say that? Tan a plus cot a whole square minus 1. Can I say that? Right? And we also know that tan a plus cot a is 2 cosec 2a. So tan a plus cot a whole square. Tan a plus cot a whole square is equal to 4 cosecant square 2a. So again, directly use this. Directly use this. So this is, okay, this is minus 2, not 1. So this is 4 cosec square 2a minus 2. So this is how I am going to read this. This is how I am going to read this. So the final expression is going to be, it is going to be 4 common cosec square twice of this angle, that is pi by 8, plus cosec square twice of this angle, that is pi by 4, plus cosec square twice of this angle, that is 3 pi by 4. Right, so pi by 8, pi by 4, 3 pi by 8. What is happening today? A lot of mistakes I'm making. Right, so this is done. 4, 4, 4. minus 2, minus 2, minus 2. So minus 6 plus 1, minus 5. So minus 5. So we are left with this. So again we have 4 cosec square pi by 8. Cosec square pi by 4. By the way, cosec square pi by 4 is known. Plus cosec square 3 pi by 8. 3 pi by 8 minus 5. Minus 5. So this is what we need to solve. Okay, this expression is known. Cosec pi by 4. Cosec pi by 4 is root 2. Root 2 square is 2. So we have, if we simplify this, you have 4 times cosec square pi by 8 plus cosec square 3 pi by 8. Cosec square pi by 8 plus cosec square 3 pi by 8 plus 8 minus 5, it is going to be 3. This is going to be 2. So plus 8 minus 5 is going to be 3. So this is the expression that we need to solve. This is the expression that we need to solve. So how do we solve this? How do we solve this? Now again, one observation I can make is these two are again complementary angles. Can you see that? 3 pi by 8 plus pi by 8 adds up to pi by 4. 3 pi by 8 that is pi by 2. 4 pi by 8 that is pi by 2. So these are again complementary angles. So cosec square 3 pi by 8 is going to be secant square pi by 8. So again, it is always better if we can have a single kind of angle everywhere. Now we have cosec square pi by 8 plus secant square pi by 8. Now one way is I can convert cosecant theta in terms of 2 theta, double angle. That I can do. The other is, we also know this identity. Cosecant square theta is equal to 1 plus cot square theta. Secant square theta is equal to 1 plus tan square theta. So we can use this also. So 4. So 1 plus cot square, 1 plus tan square, it is going to be 2 plus tan square theta plus cot square theta plus 3. So again we are back to square 1. So 8 plus 3, 11. So 11 plus 4 times tan square theta plus cot square theta. Cot square theta. So tan square theta plus cot square theta, again we can convert this into 11 plus, where theta is pi by 8 by the way. Theta is pi by 8. So 11 plus 4 times, it is going to be tan theta plus cot theta whole square minus 2 again. And again same identity. Whatever we used, whatever we learned, tan theta plus cot theta is 2 cosec 2 theta. So this is going to be 11 plus 4 times 2 cosec 2 theta. Squaring is 4 cosec square 2 theta is pi by 4 minus 2. And put the values, you will get the answer. Put the values, you will get the answer. So let us try to find the answer, final answer. It is going to be 11 plus 16 times 16 times cosecant cosecant square pi by 4, which is 2, minus 8. So 11 plus 32 minus 8 is 35. 35, that is option C, is going to be the correct answer. I hope this is clear. Right, so this was a good question, guys. This was a good question. Again, it could be solved in a lot of different ways. I do not deny that. There would be different ways in which each of you is going to solve this. But again, there should be a clear direction. You should have a clear direction. What are we going to do? Supplementary angles, identification of complementary angles, tan theta plus cot theta, wherever you find, always find. Cosec, secant, I'm very afraid of cosec and secant. So what I do is, cosecant square, I always write 1 plus cot square, secant square, I always write 1 plus tan square. I'm comfortable with, relatively comfortable with tan and cot. The easiest are sin and cos. Right? So these are the clear steps which are there in my mind, which keep on telling me that these are the steps to apply. Right? And you are that way, you should also have a clear picture in your mind what steps to apply, how to move forward. Because there are a lot of ways in which you can do this question. Right? So again, it should be very clear. The concept should be very clear. The path should be very clear. I hope this is clear, everyone. Got it? So 35 is the right answer. Moving on, question number 2. So this is more than one correct. More than one correct. Let's see. So number of real solutions of the equation tan x plus 1 into tan x plus 3 into tan x plus 5, tan x plus 7 is 33. Relatively simpler one, but again you should be having a clear path on how to proceed. How do we proceed? Tan x plus 1, tan x plus 3, tan x plus 5, tan x plus 7, 33. There will be 2 solutions in this interval, 3 solutions in this interval, 4 solutions in this interval, 4 solutions in this particular interval. So what is going to be the correct answer? what is going to be the correct answer? Now guys, very simple, very simple. Can I try to manipulate this in any way possible? So one of the most easiest ways to combine the extremes. So always try to combine the extremes. So this combined with this, this with this. So as we do, and assume tan x to be t for some time. So t plus 1, t plus 7 is going to be t square plus 8t plus 7. And second and third is going to be t square plus 8t plus 50. This is 33. Now there are two ways. One is t square plus 7, 8t plus 7. You can assume another variable k. But we can see that the mean of these two, what is going to be the mean of these two? That is the easiest way possible. 7 and 15, the mean is 11, right? So what we'll do is t square plus 8t plus 11, you assume k. Right, so we have k minus 4, k plus 4 is equal to 33. K square is equal to 33 plus 16. That is 49. K is plus minus 7. And this way you are able to solve. So you will get two equations in t. The first equation says t square plus 8t. If you assume plus 7 plus 4 is equal to 0. The second equation is going to be t square plus 8t plus 18 is equal to 0. D is clearly negative. So no solution from here. No solution from here. From here, t square plus 8t plus 4, there will be two solutions. Let us find those solutions. So minus 8 plus minus root of 64 minus 16 upon 2. So there will be two solutions, I know that. There are going to be two solutions which I definitely know of, right? So there are going to be two solutions, and by the way, both are going to be negative solutions. You can see that. If t is positive, this is never going to be 0. So both the solutions are going to be negative in nature. Exactly what are the solutions? I don't care, because I have to find the number of solutions, right? Now, clearly there are two negative solutions. If I draw the graph, so that is where the graph is very important. If I draw the graph of tan x, so this is pi by 2, this is minus pi by 2. So pi by 2, there is a dotted vertical line, and the graph looks like this. This is the graph from minus pi by 2 to pi by 2. These are the two values. So tan x is going to hit these values, two values. I don't know where are they. I don't know where they lie. I don't care also, because tan x always lie between minus infinity to plus infinity. So I do not care where they lie, but I know that both the values are going to be negative, because since d is positive, the roots are going to be real. But again, if t is positive, this cannot be 0. So t has to be negative only, right? And both the values are negative. So minus pi by 2 to 0, there are two roots, this and this. And positive side, there is no root. So minus pi by 2 to pi by 2, there are going to be exactly two values. So this is clearly wrong. This is clearly wrong. In minus pi by 2 to 3 pi by 2. Now if I extend this graph, so this is going to be pi, this is going to be 3 pi by 2. So 3 pi by 2, there is going to be one more curve of tan x, one more. So there are going to be two more solutions. So there are going to be 4 solutions in minus pi by 2 to 3 pi by 2. So A and D are going to be correct options. Right, so this was a simple manipulation. This was a simple question as far as JEE Advanced is concerned. If this comes in JEE Advanced, it would be in easy category. There are easy questions. Every year, there are going to be certain easy questions. The percentage varies. So sometimes, it can be as high as 50%, but mostly the percentage of easy questions are between 25 to 40% in case of mathematics, right? So if it comes in JEE Advanced, it is going to be coming in easy category, and you should not be missing out on these questions, and rather, you should be trying to save time on these kind of questions. Got it? All right. Moving on. This question. If the equation sin x plus cos of k plus x plus cos of k minus x is 2 has real solution, then sin of x can be. This is again more than one correct. More than one correct. So if this equation has real solution, let me write the equation if the font seems smaller to you. Sin x plus cos of k plus x plus cos of k minus x is equal to 2. So there would be certain values of x for which this is going to be 2. This is what it's saying. It has a real solution means there are certain values of x which exist so that this is going to have a solution. Awesome, Kavya. God bless you, bache. You will solve. Yeah, definitely, Prajeet. We will definitely solve JEE Advanced 23. Don't worry. With you. Always with you. Alright. Sin x, cos k plus x, cos k minus x. The first thing that comes to our mind while seeing this is, can this and this be solved? Cos a plus b, cos a minus b. You can directly write cos a plus b formula, cos a minus b. You will also know cos a plus b plus cos a minus b. So this is sin x plus 2 cos k cos x. This is 2. So this is the simplified expression. Simplified expression, sin x plus 2 cos x is equal to 2. Right. Now, what is one thing which comes to our mind after seeing this? So I can clearly see that we have an expression of sin x, we have an expression of cos x. So this is the concept of a sin x plus b cos x. Left hand side, maximum value is going to be a square plus b square, 4 cos square k. And minimum value is going to be this, 1 plus 4 cos square k. Right, so if this expression is p, so p is going to lie between these two values. If this expression sin x plus 2 cos k cos x is p, then p is going to lie between these two values, a sin x plus minus b cos x. The maximum value is root of a square plus b square, minimum value is minus root of a square plus b square. Right, so p is going to lie here, and of course p is 2 in our question. So 2 is less than equal to this, 1 plus 4 cos square k. You can solve this also. This is always going to be true. 2 is always going to be greater than negative value. So this is something that we have to solve. So you can square. The 4 is less than equal to 1 plus 4 cos square k. 4 cos square k is going to be greater than equal to 3 by 3. Cos square k is greater than equal to 3 by 4. We have to find sin k. So 1 minus sin square k is greater than equal to 3 by 4, giving us sin square k less than equal to 1 by 4. Sin square k less than equal to 1 by 4, or sin x between minus half to half. Sin k between minus half to half. So what are the values from these options which sin k can take? Minus half to half, this value and this value, because half is included. So a and b, it can't take 3 by 4, 0.75, this is 0.5. It can't take minus 0.75 because this is minus 0.5. So a and b are going to be the correct answer to this. I hope this is clear. I hope this is clear. So k is not a constant, is a kind of parameter. Right, it's a kind of parameter. The variable was x clearly. It has real solutions, so x definitely has real solutions. Right, and we know that a sin x plus minus b cos x, if x is real, the maximum value is root of a square plus b square, minimum is minus root of a square plus b square. So for certain x, this is going to have a solution. Right, so that means this value is going to be greater than equal to 2, and from here we are able to find the value. Is this clear, everyone? Is this clear, everyone? So this was question number 3 for you, right? So this is a very important concept, a sin theta plus minus b cos theta. If there is one concept which I'm definitely sure of is going to come in JEE Advanced, it is this concept. Some or the other way, this concept is going to get applied. This is what my heart says. All right, moving on. Question number 4. Let's see. Inverse trigonometry, right? And again, recent years in JEE Advanced, a lot of questions have actually come from inverse trigonometry. So this is one topic which you should not be ignoring, right? So it says theta is equal to tan inverse 2 tan square theta minus tan inverse 1 by 3 tan theta. And distinct values of tan theta are alpha, beta, gamma. So there are 3 distinct values of tan theta which satisfy this. There are 3 distinct values of tan theta which are going to satisfy this. What is going to be the value of alpha plus beta plus gamma mod? This is the question, right? So this is one thing, inverse trigonometry particularly, which has come a lot in recent times. And again, if this concept is very clear, this should give you some confidence, right? Inverse trigonometry, so there are certain chapters, inverse trigonometry, binomial theorem, differential equation, vectors 3D. So these are the 4-5 chapters which have limited syllabi, very limited syllabi. They cannot go beyond, right? But there are other chapters like normal trigonometry, calculus, integral calculus, differential calculus. There is no limit. Functions, they can go anywhere, any length, any breadth. But these are the chapters: differential equations, trigonometry. We have vectors 3D, inverse trigonometry, not trigonometry, inverse trigonometry, vectors 3D, binomial theorem, wherein differential equation, wherein the syllabi is very limited. Right? Differential equation, only 3 things are there. What are the things? What are the things? Linear differentiable, LDE, homogeneous and variable separable. Are you getting this? Vectors, only 4 things are there. Scalar triple, vector triple, scalar dot, and vector product. Take a dot product, cross product, STP, VTP, only these things. Plane, 3D, 2 things are there, plane and line. Right? So limited syllabi is there. So that is why they cannot go beyond that syllabi, because the syllabi is well defined there. Right? So these are the chapters which should not worry you at all. And if you are underconfident, these are the 10 days, these are the days wherein you have to, make sure that these chapters are upright, and you should be able to do every question which comes from these chapters. Right? So how do I approach trigonometry, inverse trigonometry in particular? So I am personally speaking, I'm very afraid of inverse. Very afraid. So wherever I find inverse, even whether it is inverse of a function or inverse of a trigonometric function, I tend to remove it. So this is the beauty of mathematics. So whatever you are afraid of, you can always remove it, right, as per your convenience. So I'm afraid of these 2 terms. So what I'll do is, I'll remove these. Tan inverse 2 tan square theta, let's say this is A, and tan inverse 1 by 3, tan inverse 1 by 3 tan theta is B. So this gives tan A is 2 tan square theta, tan B is 1 by 3 tan theta, and theta is equal to A minus B. So as I removed inverse, I found these equations. Right? So I'm afraid of this, I remove this. Let this be A, this be B. So tan A becomes this, tan B becomes this, theta is A minus B. Now how do I find tan? So taking tan on both sides, can I do that? So basically tan theta is tan A minus tan B upon 1 plus tan A tan B. And this is how I am able to remove tan inverse from my life. So tan theta is what I need to find, no issues. And everything else can be written in tan theta. For example, tan is 2 tan square theta minus 1 by 3 tan theta divided by 1 plus 2 tan square theta 1 by 3 tan theta. In fact, you can take tan theta to be t for some time, right? Because you don't have to write tan theta every time, right? It is causing us a lot of space. So what I'll do here is, let us try to simplify. So cross multiply, we have t plus 2 by 3 times t to the power 4. Square, cube and 4 is 2t square minus 1 by 3t. 1 by 3t goes here, so this is going to be 4 by 3t plus 2 by 3 t to the power 4 is equal to 2t square. 2 also goes, 2 goes, 3 also goes. So we have t to the power 4, the final equation is t to the power 4 minus 3t square plus 2t is equal to 0. 2t is equal to 0. So it's a 4-degree equation in t. It's a 4-degree equation in t. Let us try to find the root. So one root is clearly t is equal to 0. So t common, t cube minus 3t plus 2 is equal to 0. Right, so this is a cubic equation which is left in the brackets. So one value of t, that is tan theta, is 0. So maybe alpha can be 0. Okay. The other values are going to come from this. But it says there are 3 values. How are we finding? There are 4 values which are coming our way. The question is 3 values. So there must be something, which we are missing. Let's see. So let us try to solve this. T cube minus 3t plus 2. Now clearly this is a cubic equation whose one root can be found using hit and trial, which is t is equal to 1. Can I say that? One root by hit and trial clearly is visible. So t minus 1 I can divide by t minus 1. So we have t square. You can divide by t minus 1. T cube minus t square plus t plus, okay, t cube minus t square plus t square, t minus 1, t cube minus 3t plus 2, t square, this is done, it should be minus 2. Minus 2. So as you divide by t minus 1, this is the question that you're getting. And if you factorize this, this is clearly t plus 2 into t minus 1. So basically this has 3 roots, out of which 2 are equal. That is 1, 1 and 2. Minus 2, sorry. 1, 1 and minus 2. So values of t would be 1, 1 and minus 2. So these are the 4 values of this particular equation. 4 roots of this equation. I'm asked distinct values. So distinct values are going to be 0, 1 and minus 2. 0, 1 and minus 2. So these are the 3 distinct values. And clearly one of the values of tan theta is 0. So that means alpha can be 0, beta can be 1, gamma can be minus 2. So 0 plus 1 minus 2 mod is going to be 1. So 1 is going to be the correct answer. I hope this is clear. Oh, writing is not visible, is it? I think it is pretty much visible. Is everyone facing the same problem? Are you not able to see the writing? Okay. I'll use some other color, but again, I hope this is clear to everyone. Okay, the writing is visible. Okay, great. Great. Super. I hope this is clear. So 3 values of the tan theta 0, 1 and minus 2. 3 distinct values of tan theta are going to be 0, 1 and minus 2. Got it? Super. So this was question number 4. And again, this was a great question based on what are the concepts that are involved. It involved inverse trigonometry. It involved basic calculations, tan of a plus b, a minus b, and again solving of cubic equation. Right. So again, it involved a lot of multiple concepts. So these are the kind of questions which are likely to come, involving a lot of different concepts. All right. Moving on. Question number 5. If the system of equations sin x cos phi. So let me write this for you. Sin x cos y or cos 2y is equal to a square minus 1 whole square plus 1, and cos x into sin 2y is a plus 1. This system has a solution. Then the value of a plus 2 is going to be what? The value of a plus 2 is going to be what? This is the question. Okay guys, can you see me now? Can you see me now? Okay, perfect. So sin x into cos 2y is a square minus 1 whole square. Cos x into sin 2y is a plus 1. If this has a solution, this system has a solution, then what is the value of a plus 2? So a is going to be what? Again, this is a very simpler version of this particular question. Although the questions can be, there can be a lot of different versions of the same question. I'll tell you after we solve this. Okay. Okay. Now guys, in these kind of questions, you should always, one idea that you should always explore is to find the range of trigonometric functions which are given to us. Yes, so there are a lot of different things that you can do. You can add the two, sin a cos b plus cos a sin b, it can become. You can subtract the two equations, sin a cos b minus cos a sin b. This can become. I hope this is clear. Alright. The other thing, apart from adding and subtracting or divide also you can do, because a lot of terms can get cancelled out. The other thing is you should always find the range. For example, if there are two different angles, x and y as such has no correlation which is given to us. Sin x maximum value is 1, cos 2y maximum value is 1. What can be the maximum value of this? Let's say this expression is p. What can be the maximum value of p? What can be the maximum value of p? Can anyone tell me on the chat? Maximum value of t. Maximum value of p is going to be what? Maximum value of p is going to be what? So sin x maximum value is 1, cos 2y maximum value is 1. So overall maximum value is always going to be 1. And when would this value be? When both are equal to 1. Otherwise, for all other things, the product is always going to be less than 1. Right? So this value is going to be always, maximum value is always going to be 1. Are you getting this? So it is not like sin x into cos x. So when we have sin x into cos x, this maximum value is half because this angle is same. So 1 upon 2 sine. So 1 upon 2 sine 2x. 1 upon 2 sine 2x. So this value maximum is going to be half. But again, here the two angles are not equal. Right? So they can both be individually equal to 1. So maximum value is 1. Okay. Let us look at the right hand side of the same expression. A square minus 1 whole square plus 1. What can we say about this? What is the range of this? What is the range? So if A is real, guys, if A is real, can I say this value is always going to be greater than equal to 1? Can I say that? This value is always going to be greater than or equal to 1 because 1 plus some perfect square is there. 1 plus a value which is a perfect square. So 1 plus certain perfect square is there. It is always going to be greater than or equal to 1. See, only consider this. Left hand side is less than equal to 1. Right hand side is greater than or equal to 1. And if it says this has a solution, it can only be possible if both sides are equal to 1 at the same time. So this has a solution. I'm only talking about the first, not the second. If the first equation has a solution, that can only happen if both sides are equal to 1 at the same point of time. Now, when is right hand side equal to 1? So right hand side is 1 when a square minus 1 is 0 or a is plus minus 1. So a can be either plus 1 or minus 1. So this is very short. A is either plus 1 or minus 1. If a is any value apart from 1 or minus 1, left hand side, the first equation is not going to have any solution because right hand side will be greater than 1 and left hand side will be less than 1. It is not going to have any solution. So first equation is going to have a solution only when a is either plus 1 or minus 1. Now see guys, if a is minus 1, okay, if a is 1, let's see, if a is 1, let us look at the second equation. Second equation is cos x into sin 2y. Cos x into sin 2y, a is 1 is equal to 2. So if a is 1, the second equation would mean cos x into sin 2y is equal to 2. Can this happen? Can this happen? This cannot happen because the same reason, left hand side, the maximum value is going to be 1 when both are equal to 1 at the same time. Left hand side can be 1 when both are equal to 1 at the same time. Cos x is also 1, sin 2y is also 1. This can never be 2. So that means a is equal to 1 cannot happen. That means a has to be minus 1 only. If a is minus 1, a plus 2 is going to be 1. So 1 is going to be the correct answer to this. I hope this is clear. I hope this is clear. So again, this was a question which looked like it would involve certain kind of identity, sin a cos b plus cos a sin b or sin a cos b minus cos a sin b, but it was a pure question based out of range. So range is one thing which you should always and always explore, guys. Very important. Very important, right? So this is an important lesson, right? So, questions can always be deceptive. It looks something else, but it is a pure question on range. Got it? So this is it. Let's see question number 6. Question number 6. In a triangle ABC, BC is equal to 1, sin a by 2 is x1, sin b by 2 is x2, cos a by 2 is x3, cos b by 2 is x4, and some kind of, scary looking expression is given to us. x1 by x2 to the power 2010 minus x3 by x4 to the power 29 is equal to 0. Then find the length of AC. Find the length of AC. So this is what we have to find out. Find the length of A into C. You just have to tell, is it going to be greater than 1? Is it going to be less than 1? Is it going to be half? Or is it going to be 1? It is given that BC is 1. So let us draw the triangle first of all. So A, B, C. This is 1 and we have to find AC. This is what we have to find. X is what we have to find. X is what we have to find. This is 1, X is what we have to find. And some kind of difficult looking expression is given to us. I don't know why. Let's see why is this given. So A by 2, B by 2, A by 2, B by 2. So these are the values. Now see guys, A by 2, B by 2. See these are two angles. So A and B, these are the two angles which are given to us. These two angles. And we have to compare these two sides also. Right? So again guys, if I have to compare whether X is greater than 1, equal to 1 or less than 1, I can only compare the angles, right? So if I'm able to compare the angles, if this angle is greater, the side opposite to this angle is going to be greater. If this angle is going to be greater, the side opposite to this angle is going to be greater. As simple as that. I hope this is getting clear to each and every one of you, right? So if I have to say, compare the sides of the two sides of the triangle, I can always do that by comparing the angles of that same triangle. So can I compare a by 2 and b by 2 and let's see what happens. So because some expression in angles is given. So let us say a by 2, assume, is greater than b by 2. A by 2 angle is greater than b by 2, right? So if a by 2 is greater than b by 2, can I say that sine a by 2 is going to be greater than sine b by 2? Because a by 2 and b by 2 are both going to be less than 90. A by 2, b by 2 are going to be less than 90 because it's a triangle. It's a triangle, a by 2, b by 2, half angle is always going to be less than 90. So sine a by 2 is going to be greater than cos sine b by 2. Also, if this is greater than this, then cos a by 2 is going to be less than cos b by 2. Cos a by 2 is going to be less than cos b by 2. I hope this is also clear. So what does first equation mean? Sine a by 2 greater than sine b by 2. That means x1 is greater than x2. Cos a by 2 less than cos b by 2. That means x3 is less than x4. Now if this happens, sine x1 is greater than x2. So can I say x1 by x2 is going to be greater than 1 in this case? And x3 by x4 is going to be less than 1 in this case. X3 by x4 is going to be less than 1. Now see, can this happen? Can this happen? X1 by x2 to the power 2010. That means some value which is greater than 1 raised to the power 2010 and some value which is less than 1 raised to the power 29. So if a value is less than 1 raised to the power raised to the power a bigger power is going to make it even lesser. So this expression is going to be less than 1. This is going to be greater than 1. So this can never be 0. So this can't happen. This cannot happen. So let us assume the second case when a by 2 is less than b by 2. So if a by 2 is less than b by 2, so clearly sine a by 2 is going to be less than sine b by 2. And cos a by 2 is greater than cos b by 2. So again it is going to be the same case. That is x1 is going to be less than x2. x3 is going to be greater than x4. So x1 by x2 is going to be less than 1. x3 by x4 is going to be greater than 1. So again same thing. This value is less than 1. Power 2010, again a value which is less than 1. This value is greater than 1. Power 29 is value which is greater than 1. So less than 1 minus a value which is greater than 1 cannot be 0. So this cannot happen. So a by 2 is not less than b by 2. A by 2 is not greater than b by 2. So that means a by 2 has to be equal to b by 2. In other words, a is equal to b. So if a is equal to b, x is also 1 and d is the correct answer. Right, so I hope this is clear. Right, so this is how we solve these kind of equations. So whenever, this was a difficult looking expression and non-symmetric also, 2010, 29, very different values, very scary values. Right, so I knew that nothing algebraically had to happen here. Nothing algebraically, we couldn't solve this because 2010, 29 are big values, right? So this is only to scare you and you got scared. Right, so this is what we have to learn. Whenever there are difficult looking expressions in the question, most likely the question has no value. The question has no difficulty level. Why? To make the question difficult looking, they introduce this. Otherwise, they won't have, they shouldn't have, there's no need of it. Are you getting this? Are you getting this? Are you getting this? Got it? Super. Super. Moving on, question number 7th. Sigma, sigma. So double sigma. This is a problem faced by a lot of students. Sigma, sigma. Double sigma. So how do we open sigma, sigma? So again, sigma, sigma tan inverse r by s. S varies from 1 to 10, r varies from 1 to 10. Is it 55 pi? 50 pi. Coefficient of x to the power 15 in the expansion of this. Coefficient of x to the power 25 in the expansion of this. So by the way, we can find this and this, both of these. So 25 pi x into 1 minus x to the power minus 1. So 25 pi x. So you should know that how this expression opens up. This is 1 plus x square plus x cube and so on. Right, so this is going to be 25 pi x plus x square plus x cube plus x to the power 4 and so on. So basically every coefficient is 25 pi. So this is actually 25 by indirectly given, and likewise we can solve this. So basically if the option is no, not this, this or this, we will put a tick on B. So we there was no need to solve both of these. This is what I'm trying to say. This is how you can save time, and this is how you should save time. So this is direct value, this is direct value. Most likely if this is given, the answer is not going to be from A and C, because they want us to solve these. Now smart thing is not to solve both. Solve any one. Because if the answer is not out of A, C and D, the answer is going to be B. As simple as that. Got it? Now let us do this. So how do we expand this? Now the thing is, we should be starting from the inner. So S varies from 1 to 10. So keep R as it is. So it is going to be sigma. R varies from 1 to 10. The first term is going to be tan inverse R by 1 plus tan inverse R by 2, tan inverse R by 3, and so on up to tan inverse R by 10. So these are the 10 terms. 10 terms. So what I've done is I put S is equal to 1 plus S is equal to 2, S is equal to 3, and so on up to S is equal to 10. Now I'll vary this. Can I say if I apply sigma on the first term, this is going to split into 10 further terms. So if I apply sigma here, only here, so it will be tan inverse 1 by 1 plus tan inverse 2 by 1 plus tan inverse 3 by 1 dot tan inverse 10 by 1. So this has been split into further 10 terms by applying this sigma here. Similarly, second, tan inverse 1 by 2 plus tan inverse 2 by 2 plus tan inverse 3 by 2 and so on up to tan inverse 10 by 2. Third, tan inverse R by 3, 1 by 3, tan inverse 2 by 3, tan inverse 3 by 3 and so on tan inverse 10 by 3. Likewise, tan inverse 1 by 10, tan inverse 2 by 10, tan inverse 3 by 10 up to tan inverse 10 by 10. So these are total of 100 terms here written in this matrix. So first row 10 terms, second row 10 terms, third row 10 terms, total of 100 terms have to be combined. Now guys, this is very simple. Now if you are able to identify this matrix and find this, you should be able to see that apart from this diagonal, leave apart this diagonal, every other term is going to be reciprocal of each other. For example, reciprocal of this term is going to be this. So if there is a term tan inverse P by Q, there is going to be some term tan inverse of Q by P also here, and always symmetric. 3 by 1, 1 by 3, 3 by 2, 2 by 3. So every term is going to have its reciprocal, and we know that tan inverse of P by Q plus tan inverse of Q by Q is equal to pi by 2. Something we know that. So these are 100 terms. Take these 90 terms. Take these take these 10 terms away. So total of 90 terms are there, which can be coupled into 45 pairs. 45 such pairs. Can I say that? Because tan inverse of 2 by 1 and 1 by 2 is going to get combined. 3 by 1, 1 by 3 is going to get combined. 10 by 1, 1 by 10. So again, there is going to be symmetry here. So every pair here is going to get coupled with this, and there are going to be 45 such pairs, and each pair has a sum pi by 2. So it is going to be 45 pi by 2 for these 90 terms plus these 10 terms. What are these 10 terms? Tan inverse of 1 plus tan inverse of 1 plus tan inverse of 1 up to tan inverse of 1. So this is 10 times pi by 4. Every term is pi by 4. This is 5 pi by 2. 5 pi by 2. So plus 5 pi by 2. This is 50 pi by 2 or 25 pi. 25 pi, this means option D is the correct answer. As simple as that. 25 pi is going to be the correct answer. That is option D. Right? So this is how you apply systematic calculations here. Otherwise, if you had applied, sigma, both sigma at the same time, you would have definitely gotten confused. Right, so this is how we apply symmetry. We use matrices. Are you getting this? Are you getting this? Right, so this was another amazing question on inverse trigonometry. Right, so again, what I taught you here is to apply symmetry to, distribute it in a good way so that you are able to take the help of symmetry and solve the answer. Got it? Got it? So 25 pi is the right answer. I hope this is clear. Alright guys, so again the questions for today were very less because again there are very less days which are left. So I don't want to greatly involve you into calculations and stuff. What I'll do here is there are a couple of things which in my mind for the coming week. So one is we've majorly covered all the basic units. We've covered integral calculus, differential calculus, algebra 1, algebra 2. We've also covered the conic section. So one thing which is coming to my mind for the next week is this mock tests, right? So we can have certain individual mock tests of mathematics, and then we'll have a combined mock test. So again, I think the time for individual units is over. Now is the time to combine the questions, combine the multiple concepts, again give it to you in the way JEE Advanced asks. So one thing which is there in my mind is to do mock tests of mathematics, at least 2 or 3, and then some combined mock tests with all the 3 subjects together. So this is one thing. If apart from this, if you want any other thing from me, you can always put that on the comment section or get in touch with me in Telegram. And if I see that there is a lot of demand, a lot of you are asking for the same thing, I'll definitely bring that session. Yes? Super. Super. Right. So these are the homework questions. Again, the PDF is going to be attached in the Vedantu J English channel. I'm going to attach it. So you can do these questions on your own, right? So these are standard questions on trigonometry. So if particularly you are very weak in trigonometry, then you can attempt. Otherwise, you can skip these. But just remember the points which I told you at the start of the session. Those are important points. And again, a lot of questions have come based on those concepts. So these are very standard, typical questions which you can attempt only if you are very weak in trigonometry, right? Otherwise, you can skip these. Just very standard questions, right? So I'll just show you these questions. So these are very standard. Okay, and this is the good question, sigma, right? How do you solve this? Very important, very good question. Okay, and another standard question, right? So that is it, guys. I hope you enjoyed this session. If you did, just like the session. That is one, and also give me on the comment section what else apart from these you want. My idea is to give you mock tests. If anything apart from mock tests you want, just put that on the comment. Take care. God bless you. Bye everyone. Love you all.